This year I had entered a plant growing competition, but when I saw my plants had no energy to grow, that's when I knew I had to call candidate chloroplast. When I saw what candidate chloroplast did to help my plants grow, I knew he was the candidate to rely on. Candidate chloroplast is able to turn sunlight into sugar, which is energy that my plant needed to use to flourish. Candidate chloroplast has helped us out with a lot of things. As you know, chloroplast plays a major role in the process of photosynthesis, which allows sunlight to be converted into energy for plants. If plants didn't have chloroplast, then they wouldn't be able to convert energy from themselves and they wouldn't be able to flourish. If there were no plants, that would cause a chain reaction in our world, causing basically all living things to not be alive and to diminish. Candidate chloroplast is responsible for 70% of oxygen found in the atmosphere, and here's how. Nearly all plant cells have chloroplast to survive, and during the daytime, plants will absorb the sun's energy and photosynthesize. During photosynthesis, oxygen is released into the atmosphere that many living organisms need to survive. Chloroplast is unlike any other campaign organelle we've ever seen before. We can definitely rely on candidate chloroplast because throughout the hundreds and thousands of years, we've constantly been able to see that the photosynthesizing process of plants has flourished as we are still here today. If you vote for candidate chloroplast, you will not be disappointed. Vote for candidate chloroplast. Today's energy for tomorrow's future. Thank you.
This just in from our informants at Channel 4. The chloroplast organelle that exists solely in photosynthesis performing plant cells is utterly integral in upholding all life on Earth. Chloroplasts themselves are in every plant cells, which facilitate the construction of sunlight into usable ATP energy molecules for the cell. In doing so, the chloroplast upholds function in its cell, the larger multicellular autotroph, and the ecosystem overall. Furthermore, our sources confirm that the chloroplast organelle provides metabolic activities for its individual cell, including synthesis of fatty acids, membrane lipids, isoprenoids, tetrapyrols, starches, and hormones. Productivity of the previously mentioned biomolecules increases environmental requisite of the chloroplast, especially when it comes to surviving biotic and abiotic stresses to the health of the cell and the larger autotrophic organism. Drought, cold, heat, oxidative stresses, and deprivation of phosphates are all possible causes for cell degradation that the chloroplast's functions prevent. Any organelle skeptic might wonder what really makes them tick. Well, you see, my friends, chloroplasts are structurally enclosed by an envelope of membranes, which encompasses a third membrane that houses the process of photosynthesis. In greater detail, the outer membrane of the chloroplast is permeable to small organic molecules while maintaining organelle structure, although the inner membrane is permeable and studded with proteins. In addition, the innermost layer of a chloroplast is called the stroma, which is a transparent liquid that contains multiple copies of the chloroplast genome and surrounds the thylakoid suborganelle used for photosynthesis. Heading into even more detail, grana are stacks of thylakoids that exist within the chloroplast to habilitate light-dependent photosynthesis reactions imperative to cellular function. Without the minute details of how every granum is organized and interconnected by the stromal lamellae, the productivity and ability to support the cell through photosynthesizing of each thylakoid, and in turn each chloroplast, would decrease significantly. Chloroplasts, to end the seed of discussion, provide the very basis for every system of trophic levels and relationships throughout the entire biosphere, starting at the incredibly diminutive organelle level of perception. Thank you.
Are you sure you want to trust the mitochondria? Although it may be the powerhouse of the cell, it's also a powerhouse for failure. Even if you are healthy, mitochondria deteriorates as you get older. Malfunctioning mitochondria has been linked to diabetes, Alzheimer's, Parkinson's disease, and even premature aging. Dr. Vamsi Mutha of Harvard Medical School says, if we can learn more about the rare mitochondrial disorders, the findings could have implications for understanding more common diseases. And I trust him more than I trust the mitochondria, to be honest. Ribosome, essential for a healthy life, constructing all the protein cells need to grow. They can do their job correctly, right? Wrong. Ribosome failures can result in bone marrow disease, anemia, and later in life, cancer. These abnormalities even have their own name: ribosomopathies. Vacuoles are pretty cool, right? Seems trustworthy, being the storage for the cell. Contrary to popular belief pushed by the non-chloroplast media, the vacuole is actually a very dangerous organelle. When a vacuole malfunctions, it can result in Danon disease. Men with Danon disease usually die at the very young age of 19, whilst women dying in their early 30s. Danon disease is caused when there is a mutation in the LAMP2 gene, which helps with the fusion of autophagic vacuoles and lysosomes. Because the autophagic vacuoles fuse with the lysosomes very slowly with Danon disease, it causes a number of autophagic vacuoles to increase substantially, resulting in the breakdown of muscle cells.
Nucleus. Heart failure.
Cytoskeleton. Sickle cell anemia.
Endomembrane equals misfolded protein. Wasted energy can't be trusted.